Welcome to The Explainer. Today, we are bringing you a definitive masterclass on one of the absolutely most widely used and, let's be honest, occasionally misunderstood mechanisms in the universal verification methodology, the UVM Config DB. If you've ever spent hours pulling your hair out debugging why your driver just isn't getting the right interface, well, you are in exactly the right place.
All right, hooking you right off the bat, let's talk about the core headache literally every verification engineer faces. SystemVerilog gives us this beautiful, object-oriented, dynamic environment for our test benches, but at the end of the day, that dynamic environment has to actually drive physical, static hardware signals in the device under test. So how on earth do we pass those structural pointers down through heavily nested, dynamically created test bench hierarchies without breaking all the rules of object-oriented scoping?
Okay. Let's dive into this. Here's our roadmap for today. 1. Meet the UVM Config DB. 2. Mastering set and get. 3. Scoping with wildcards. 4. Passing virtual interfaces. 5. Routing configuration objects. And finally, 6. Config versus resource DB.
Starting off with Section 1, meet the UVM Config DB, or as I like to think of it, the test bench post office. Imagine the configuration database as a highly specialized postal service for your test bench. It allows a component, like your top-level test, to just mail a package, say an interface or a parameter, to another component, like a driver way down deep inside an agent, without the two ever needing to be directly connected or even aware of each other's exact hierarchical path.
Now, looking right at the official UVM 1.2 class reference manual, we can see the exact definition. The UVM Config DB is a parameterized class. But here's an absolutely crucial detail. All functions within the config DB are static. That means you literally never instantiate the database itself. You're always going to interact with it using that scope resolution operator. Officially, the manual defines it as a convenience layer built on top of the underlying UVM resource DB. But that word convenience is doing a lot of heavy lifting there. What it actually does is strongly bind the database to the structural hierarchy of your UVM component instances. It ensures that any data sharing completely respects the parent-child topology of your specific test bench environment.
Moving right along to Section 2, mastering set and get. We're talking about mailing and receiving packages here. Because if the config DB is our postal service, well, set is how we drop a package in the mail, and get is how we check our mailbox to receive it. Straight from the UVM standard, check out the static method signatures for setting and retrieving data. Notice how both set and get require 4 arguments? That's the secret sauce. If you can master these 4 arguments, you master the entire database. So to make this incredibly easy to memorize, I like to break these 4 arguments down visually into the address and the package. The first 2 arguments, the context and the instance name, they form the scope. That is your shipping address. It dictates exactly where in the test bench hierarchy the data belongs. Then, the last 2 arguments, the field name string and the actual value, they make up the package. It's essentially the label on the box and the payload packed inside. All right, Section 3, scoping with wildcards, or broadcasting your packages. Now that we know exactly how to mail a single package, what if we want to mail that exact same package to an entire department? Now, what's really interesting about this is just how wildly flexible that scoping address can be. Your context can be set to null, which means you're acting from the absolute root of the simulation, the UVM top. Or if you're already inside a component, the context can simply be this, referencing your current location. But the real magic, that's the instance name. It supports glob-style regular expressions. By simply tossing in an asterisk, you can broadcast a single set command to propagate a configuration right down to multiple child components simultaneously. Literally no repetitive code required. Section 4, passing virtual interfaces. Let's bridge those static and dynamic domains. It's time to apply this theory to arguably the most common task you're going to face on any verification project. Just a super quick refresher before we look at the code. A virtual interface is really just a dynamic handle, a physical pointer essentially, that allows your class-based UVM components, like your drivers and your monitors, to reach out and physically toggle or read the static pins on your Verilog device under test. To pull this off, we follow a pretty strict 3-step workflow. Step 1 happens up on your static top-level test bench module. You instantiate the physical interface. Step 2, still up in that top module, you use the set function to place a virtual handle of that interface straight into the config DB. Then, step 3 happens all the way down in the dynamic UVM domain. Your driver or monitor uses get during its build phase to fetch that handle.
So what does that actually look like in the code? Here is a real-world snippet of that crucial set command. We're calling UVM Config DB, parameterized with a virtual APB interface type. Notice our context is null. That's because we're calling this from a static module, not a UVM class. The target instance path uses a wildcard, UVM desktop.star. We are naming the resource VIF, and the payload we're passing is the APB VIF. It's beautiful, it's clean, and it's highly effective. Moving to Section 5, Routing Configuration Objects. Let's talk about scalable testbench management, because honestly, the database isn't just for interfaces. Let's look at the second major use case. As your test benches scale up, you're going to have dozens of parameters. Active and passive switches, coverage toggles, base addresses, the whole shebang. Instead of passing these one by one using dozens of messy set calls, we group them into a single configuration object class. You instantiate and randomize this object in your top-level test, push the entire object into the config DB, and then just let your lower-level environments and agents pull that single object down. This structured approach is exactly what keeps massive system-level test benches clean, scalable, and fully reusable. And finally, Section 6, Config versus Resource DB, the database showdown. Understanding this expert-level nuance is absolutely what separates the novices from the senior verification architects. And this brilliantly illustrates the difference. The underlying UVM Resource DB uses a flat scoping engine and a strict last right wins conflict resolution. But the UVM Config DB adds that hierarchical context. Because of this, during the UVM build phase, the Config DB actually enforces a parent wins rule. This is vital. It means a top-level test can set a configuration that overrides a default configuration set deep down by a lower-level agent. The parent's configuration simply takes precedence, no matter the execution order.
But hold on, because there are some massive caveats here you need to know about. Once the build phase ends and the simulation starts running, the config DB actually reverts back to last right wins. Furthermore, because the config DB relies so heavily on component hierarchy, it is notoriously awkward to use inside transient objects like sequences. To get config data into a sequence, engineers historically had to create these really messy p-sequencer workarounds. But get this, if you just use the flat UVM Resource DB directly, you can access data from anywhere, totally eliminating the need for p-sequencer. In fact, the UVM Config DB was originally just a transitional API added to UVM to provide backward compatibility with the older OVM methodology. Crazy, right?
And this hidden architectural history has actually caused a bit of a paradigm shift lately. As renowned verification expert Cliff Cummings points out, the mistake the industry made wasn't adding the config DB. It was necessary for the OVM transition. The mistake was using and promoting it as the primary interface. For many tasks outside of structural build phase routing, the underlying Resource DB is actually so much more powerful and flexible. So, having mastered the postal service of UVM, understanding exactly how to package, address, and broadcast your virtual interfaces and config objects, and now knowing the hidden history of the config DB versus the Resource DB, I'm going to leave you with this question. Which database are you going to reach for to architect your next test bench? Think about it, definitely experiment with it, and keep building those robust environments. Thanks so much for joining.